Welcome dear students, myself Rambabu, Physics faculty from Nuclear Academy, Bangalore. In the previous session, we studied about what are the properties of charge, what are the charging methods and explanation about the gold leaf electroscope. So in this video, we are going to we are going to solve the MCQs on properties of electric charge. So coming to the properties of electric charge, there are three properties will be there. So what are those three properties? The first property can be taken as charge is quantized and charge is conserved and charge is additive. So depend upon those we are have to take the some problems, and also here in this we are going to do problems related to the charging methods also. Correct? So see what are the MCQs related to methods of charging and also properties of electric charge. So here see first question. If two bodies are rubbed and one of them acquire a charge q1 charge and another one is acquired q2 charge, then what is the ratio of the charge q1 is to q2? Now here two bodies are rubbed means this is known as charging by friction. This is known as charging by friction. According to charging by friction, then a body can lose the electrons, can obtain the positive charge, and a body can gain that electrons and acquiring the negative charge. How much charge lost by the body? The same charge is acquired by another body, but one become positive and another one is become negative. So during the charging by friction, the charge q1 and q2 are equal, but in opposite. Option C is the answer. And next question is here. An object of mass 1 kg, the given object of mass 1 kg contain 4 into 10 to the power 20 atoms. If one electron is removed from every atom of this given solid, then the charge gained by the solid of 1 gram is. Okay? So here they given 1 kg of the substance. Object is given as 1 kg. It is containing 4 into 10 to the power 20 atoms. But the question they given, we need to find what is the charge gained by the solid of 1 gram only. So first we have to identify how many number of atoms present in 1 gram. So to get here 1 kg of substance is having 4 into 10 to the power 20 atoms. Now 1 kg is nothing but 1000 grams. 1000 grams are having 4 into 10 to the power 20 atoms. From this 1 gram is having 4 into 10 to the power 20 divided by 1000. So here we obtain 1 gram of the substance will have the amount of atoms is 4 into 10 to the power 17 atoms are there. Now each atom we remove 1 electron, then 1 gram is having the charge q is equal to, here number of atoms are 4 into 10 to the power 17 and charge of atom electron can be taken as 1.6 into 10 to the power minus 19. Finally, simplifying this one, we obtained it as 6.4 into 10 to the power minus 2 coulomb. So this is the charge gained by the solid of 1 grams. First 1 kg is containing these many number of atoms. In that 1000 grams is containing how many? Same. From that 1 gram is containing these many atoms. From each atom 1 electron is removed. From each atom 1 electron is removed means how many electrons we removed? Number of atoms into charge of electron, and both can be multiplied. This is the charge gained by the solid of 1 gram. Okay? Here option B is the answer. This is based on the quantization of charge. And next one is, see another question. The number of electrons that must be removed from an electrically neutral silver dollar to give a charge of plus 2.4 coulombs is. So here the question is, how many number of electrons must be removed from the given neutral silver dollar, then the silver dollar can obtain the plus 2.4 coulomb. So here it is comes under quantization of charge. Formula for quantization of charge is N into E. Here we are going to calculate the value of number of electrons which are removed from the given silver dollar, which is N is equal to Q by E. Here the charge acquired by the silver dollar is 2.4 coulomb, and charge of electron is 1.6 into 10 to the power minus 19. So here simplifying this one, I am going to write it as 2.4 divided by 1.6 into 10 to the power 19. 2.4 by 1.6, it can be taken as the 0.46 times, 0.44 times into 10 to the power 19 taken numerator, 10 to the power plus 19. And 6 by 4, which is nothing but 3 by 2, 3 by 2 is known as 1.5 into 10 to the power 19 electrons are removed, then the silver coin can be obtained as 2.4 coulomb. So here option can be taken as 1.5 into 10 to the power 19 electrons. Next question. Here a polythene piece rubbed with wool is found to have a negative charge of 6 into 10 to the power minus 7 coulomb. The number of electrons transferred to polythene from wool is. So here how many number of electrons are transferred from polythene to, means transferred to polythene from wool. So here also we are going to take the condition quantization of charge. According to quantization of charge, Q is equal to N into E. Here we are going to take how many number of electrons are transferred whenever both are rubbing on each other. When both can be rubbing on each other, number of electrons transferred is nothing but Q by E. Here Q value is given, how much charge obtained, but this one, that is 6 into 10 to the power minus 7 coulomb. Actually it is the negative charge because electrons are gained, but we take only magnitude of charge 6 into 10 to the power minus 7 coulomb divided by, here how many number of, means charge of electron can be taken. Charge of electron is 1.6 into 10 to the power minus 19. So here charge is also taken in the coulombs, and coulomb can be cancelled. It is 6 by 1.6 into 10 to the power minus 19 taken numerator, it become 10 to the power minus 7 plus 19, that is 10 to the power 12. And after that it is written as 60 divided by 16 into 10 to the power 12. So once we simplify this, here 60 is divided with 16. When 60 is divided with 16 3 times, 48, 2, 1, again 0 can be taken, 16 sevens. 16 sevens can be taken as 112, it is 8.0. Here already here point can be taken, here point, and it is 3.75. So finally what is the number of electrons gained by that polythene, that is how many number of electrons transferred from wool to polythene, can be taken as 3.75 into 10 to the power 12 electrons. Option D is answer. Okay, simple quantization of charge concept can be used here. And next one is, here if a body gives out 10 to the power 9 electrons per second, how many number of electrons given per second? Now the charge is nothing but 10 to the power 9 into 1.6 into 10 to the power minus 19 per second. So this is the charge per second gained by it. So here the charge per second gained by that body is 1.6 into 10 to the power minus 10 coulomb per second. So this is the charge gained by the body and in each and every second. Now here question is, what is the time required to get a total charge of 1 coulomb? What is the time required to get a total charge of 10 coulomb? The time is nothing but total charge divided by charge per second. Total charge divided by charge per second. Here total charge is nothing but 1 coulomb divided by charge per second. Charge per second is 1.6 into 10 to the power minus 10. Charge per second can be taken as 1.6 into 10 to the power minus 10. So here the time required is 10 to the power 10 taken numerator, 1 by 1.6 is 0.625 into 10 to the power 10 seconds. But here options given in minutes, hours, days and years. So first I have to convert the second into hour, year. So for that I am going to take 1 year is equal to, it is having 365 days, each day is having 24 hours, each hour is having 60 minutes, each minute is having the 60 seconds. So here seconds. From that second can be substituted as the time required is equal to 0.625 into 10 to the power 10 divided by 365 into 24 into 60 into 60 year. 1 second is equal to 1 by this value. 1 second is equal to 1 by 365 into 24 into 60 into 60 year. So finally simplifying this one, it is approximately 198 years. Whenever per second 10 to the power 9 electrons are gives out by the body, then that body obtaining the 1 coulomb after 198 years. Option D is the answer. But procedure remember, total charge acquired by body by charge per second given out by the body. So based on that we solve this type of question. And next, see this last question. Here, which of the following charge cannot be found in nature? So for that I am going to take quantization rule. According to quantization of charge, according to the quantization of charge, we know that Q is equal to N into E. If N is equal to 1, the charge is nothing but 1 into 1.6 into 10 to the power minus 19 coulomb. It is 1.6 into 10 to the power minus 9 coulomb is exist. Next, if N is equal to 2, Q is equal to 2 into 1.6 into 10 to the power minus 19, which is 3.2 into 10 to the power minus 19 coulomb. Means integer can be taken. N value must be integer. N is equal to 1, 2, 3, 4, 5, 6. Don't take any fraction. For example, if N is equal to 3, that is charge can be taken as 3 into 1.6, 4.8 into 10 to the power minus 19 coulomb is exist. Similarly, if N is equal to 4, then Q is equal to 6.4 into 10 to the power minus 19 coulomb is exist. And similarly, if N is equal to 5, Q is equal to 5 into 16, 8 into 10 to the power minus 19 coulomb exist. If N is equal to 6, Q is equal to 1.6 into 6, 9.6 into 10 to the power minus 9 coulomb. So whenever we are going to observe all these given charges, 3.6 is exist, 9.6 is exist, 9.4 is exist, but 3.6 does not exist. So this is our option which does not exist. So here an integer multiple of the electron can be, fundamental charge can be exist. 3.2, 9.6, 6.4, these all are the integer multiple of the charges. These will exist, but 3.6 is not possible. Here option A is the answer. So like that, we are going to solve the problems which are given on the basic properties of a charge.